we need to be aware of data playing a huge role. And you know, you can prompt something like, you know, stable diffusion, one of these, you know, fancy prompts, you know, spiral staircase, going deep down, dark side, whatever, you know, and you get some very nice image, and say, wow, this is so cool. It's a image kind of so perfectly matching the description, and, you know, never seen anything before. Well, actually, if you go to the Lion dataset, which is 5 billion images, you know, there's actually real images that are not that different, okay? So again, it could very well be that, okay, it's not doing nearest neighbor, it's doing some sort of interpolation, perhaps, but interpolation is in a very, very high dimensional space, sometimes could be indistinguishable from magic, okay? But I think we should be aware of the fact that really, you know, you can't have something out of nothing here. You have to have the data. In fact, this is something that we were wondering about for a while, and we have a new paper coming up at ICCV this year on trying to see for a given synthetic image, what are the images in the training that is most responsible. So the task is, given a synthetic image, which training images influence it the most, okay? The main problem with this task is that how do you even know when you're right? How do you know the ground truth? Well, there is the obvious way to do it is you take one image, you retrain your whole model with all the images except that one, and you see if your result got any worse. And if it did get worse, that means that that image was responsible. But that's, of course, completely infeasible for 5 billion image data set. And so what we did is we actually constructed our own training data. We started with a standard diffusion model that can produce things like these little doggies. And then we applied one of those custom diffusion methods, like custom diffusion or Dream Booth is another one, that said, okay, fine-tune the model on this particular dog picture and use that to put that dog in the scene, okay? So if there is a number of methods that came out last year that can do this for you, okay? And so you can do it for many different tasks, and you can have your own dog and all of these pictures, okay? The cool thing is now we have, by construction, we created synthetic images that are influenced by this particular example image. Like we just constructed this data to have the influence that we want, okay? And now we can use that data to train our attribution algorithm to see if we can actually, you know, apply it to real images, okay? So we also did this with artistic style, the same thing. So we have a data set, the data set is online, everybody can use it. Here is another example of a different dog. And now actually it's a very simple problem, because given a synthetic image, now you know that you want to find out, you want to compute, you want to create a feature space in which the correct, the most influencing image is closer in that feature space to the synthetic image, and all the other ones are farther. Okay? Well, this is just a distance learning kind of setup that we all know how to do. It's not that hard. Contrastive learning, mumbo jumbo, yes, 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 and you can make it work, right? It's really, again, all about the data, and this is basically what our algorithm did. And then we can take this algorithm and we can apply it to new images and basically able to estimate the influence of that image of the various images within the 5 billion image data set on this synthetic image. Okay, so that's just, by no means is this solving the problem. There's tons of work still to do, but at least it's we're barking up this tree, and hopefully others will follow